Today's lesson is about vertex form and about using vertex form to generate an equation. So yesterday's lesson was about generating an equation from using an equation to generate a table. So and manually, like automatically generating that without a calculator. Okay, like the quick and easy trick to graphing and making an equation. What we're going to do now is we're going to look at what happens if all I have is a little bit of information. How can I write a quadratic function with it? Okay. Now, I'm just going to be honest with you. I know that this problem with the vertex form is, I know that it's quadratic because there's a couple of things that tell me it's quadratic, besides the fact that we're in the quadratic unit. Let me read the question to you first. It says, a rocket was launched from a height of 16 feet from the ground and reached a maximum height of 160 feet in 3 seconds. Well, first of all, I see a couple of kind of important keywords. Okay, the first keyword that I see, I'm finding a highlighter, first keyword I see is maximum. Okay, maximum tells me that I have a maximum, and maximum also tells me something about what my parabola looks like. I mean, even then I said I have a maximum, like I'm thinking about this going up and then coming down. It also talks about a rocket. Okay, quadratics usually talk about rockets, they talk about kicking balls, they talk about area. So we have some kind of things, anything that deals with gravity. So anytime we have gravity, like a rocket, it goes up and gravity catches it and drops it back down on the ground. We have a ball, the ball goes up, gravity catches it and throws it back down to the ground. So when we talk about things that involve gravity, we're talking about quadratic functions. And so I know this is quadratic because it says a rocket and they're talking about a maximum. So we're gonna do some more problems like this tomorrow. But for now, I want us to just look at what information they've given us. Okay. So it says it was launched from a height of 16 feet from the ground. So that means when it took off from the ground, I had a point 0, 16 right there that it took off from. Okay, that's where it started. And the highest it got was 160 feet in 3 seconds. So in 3 seconds, it went 160 feet. And this is my max. And that coordinate is 3, 160. Okay, so knowing what we know about quadratics, okay, I want you to start by telling me, well, I kind of might have already said it, but whatever, you can say it again. My maximum, what coordinate is that, and my my starting point of 16 feet off the ground, what type of important value is that? So what do we know those things are called? What are their math names? Okay, so hopefully what you've come up with is that this right here is my y-intercept, and this right here is my vertex. Okay, so knowing that, I'm primed for vertex form. Now, this is what's kind of interesting. We know our vertex is 3, 160. Okay, but then they have x comma f of x. That is a coordinate. Okay, why are we using? We're using f of x to represent y. Okay. This is the exact same thing as xy. You guys are going to try and make this super duper complicated, okay? You're going to be like, oh my gosh, it's f of x is just your output variable. It's a variable, okay? It's nothing special. You don't need to treat it differently, okay? They gave me this ordered pair, though. They gave me 0, 16. With what I have here, I have everything I need to find a, that's the only thing that's missing, and write a quadratic function to figure out exactly what this function is. Okay, so that's what I'm going to show you how to do today. Use just this little bit of information. So this is a situation that we have. We're going to do a bunch of practice problems where we talk about how we would find it, but this is the kind of situation that we would use that in. If I launch a rocket from 16 feet off the ground, it reaches a maximum height of 160 feet after 3 seconds. What function can I write a function equation that I could use to describe the situation? Okay, so let's start by using this example. And for this, we're going to actually write these problems on our paper, and you can kind of tape this in. When we get to class tomorrow, you can just tape this in on the side, and you can see it. Okay, so it says a rocket was launched from a height of 16 feet. So we already wrote down what our two coordinates are. We have the vertex at 3, 160. So we know that we have vertex is 3, 160, and we have our y-intercept, and it could be any point. It just happens that it's our y-intercept this time at 0, 16. Okay, now let's take a look at vertex form. It's It says f of x. I'm going to say y because y'all freak out about f of x. Y equals a times x minus h squared plus k. And remember, this formula is on your formula chart. You don't have to memorize it. Okay? So, let's look at all the things I have. My vertex. How can I label my vertex? What letters can I use for my vertex?
Hannah Bolden to come to the front office, please. Hannah Bolden, come to the front office.
Okay, so she's probably winging her way to the front office now. Okay, so I have two parts of my equation. My vertex is in HK format. So what that means is that this is H and that's K. So I'm going to write down what I know. I know that H is 3. I know that K is 160, okay? So I've got H, I'm just going to circle the things that I've got, okay? Or I've got H, and I've got K. Now, I see X, Y, and A, okay? So H and K came out of this function, okay? Now, I'm gonna look for and see if I can figure out what other points I have, okay? So I see an x and y combination right here. Okay? I see that an x and a y here. Okay? So I have x is 0, y is 16. Now, do you guys remember something else that we did that kind of used this? Similarly, where we had to find one thing. You may or may not remember it, but point slope form was similar. We had y minus y1 equals mx minus x1. So if we had 2 points, we could plug them into x and y, and we could plug our 2 points into that formula and use it to find the slope. Or we could, if we knew the slope and the point, we could plug them in. Well, it's the same thing here. I have x, y, h, and k. The only thing I'm missing is a. So I can use these points to figure out what a is and then write myself an equation in vertex form. So let me show you what that looks like, okay? I've written down over here all of my important information, okay? So I'm going to start substituting into this equation, okay? So y equals a parentheses, x minus h, close parentheses, squared, plus k. Well, now my y is 16. I don't know what a is, so I'm going to leave it like that. My x is 0. My h is 3. My k is 160. Okay? So what I'm going to start doing is I'm going to start working from the inside out using, using order of operation. Okay? So 0 minus 3 is negative 3, and I'm going to rewrite every step. Now, this is a place where some of you are going to make a mistake. You're going to put, instead of putting negative 3 squared into the calculator, you're going to put negative 3 squared. You notice what's different here. In my equation, negative 3 is in parentheses. I'm going to put it exactly like I see it. I'm not squaring 3 and then taking the opposite. I'm squaring negative 3. That means negative 3 times negative 3, which is positive 9. Now, you notice also it's like A9. Is that how we write? We always put the coefficient first. So now we're going to say 9a. And again, we're doing that because negative 3 squared is 9, but we don't write the number after the variable. We write the number first. We always put the coefficient first. Okay? So first I did that. Then I did this. Now I'm going to start solving this equation. 9a equals 16 minus 160, negative 144. And I'm going to divide both sides by 9. And I get negative 16. So now I know that a is negative 16. So now I can write my equation in vertex form. So remember, vertex form, the only things I'm going to substitute into vertex form are A, H, and K. So we can go ahead and I'll find another color because I've got a billion pens. We're going to substitute in A, H, and K. Okay? So I'm going to write y equals negative 16. X stays the same minus h, which is 3, squared, plus 160 which is k. I can use this function to find anything else that they ask me to. Again, I can put it in my calculator and I can look at the table, I can look at the graph, I could generate my own table using the strategy we learned yesterday. So I have a lot of options. Okay? So that was the first example. I'm going to do another example with you, and then I'm going to let you try one on your own. We'll see how that goes. Okay? So we're using the examples here, but there's not enough room on here, so I want you to write them in your notes. Okay? So number 1 says, a quadratic function with a vertex of 3, negative 5, and passes through the point 1, 9. So I have a vertex of 3, negative 5, and I have a point 1, 9. Now, why am I writing this? Because I need to know what these values are. I need to know which one's the vertex, which one's the point, because the vertex is hk and the point is xy. I need to know which ones those are. So I know that the vertex is in hk format and a point is in xy format. So I'm going to write that information. H equals 3, k equals negative 5, x equals 1, y equals 9, and I don't know what a equals. A is the big mystery, okay? This is the information that I have available to me, okay? Now, I'm also going to write the vertex form. That's not y, that should be k. I'm going to write vertex form because that's going to tell me exactly what to substitute, and I can write those numbers right below to make sure I'm substituting them in the right place, okay? So, y is 9. I don't know what a is. X is 1. H is 3. K is negative 5. Okay? So I'm going to start from the inside using order of operations. You know, remember if we need to, PEMDAS or GEMDAS, whichever one you prefer. Okay? We're going to start with inside of our grouping symbols. So 1 minus 3. 9 equals a times 2 squared. And then instead of saying plus minus 5, I'm just going to say minus 5. Now I'm going to square that, and I get 2 squared is 4. But A4 looks crazy. Instead of writing A4, I'm going to write 4A minus 5. Okay? And now I'm going to start solving. I add 5 to both sides. I get 9 plus 5 is 14. 14 divided by 4 is 3.5. Okay, so my a value is 3.5. So when I write my function, y equals 3.5, that's a. I'm going to substitute an h and k. So x stays the way it is. H is 3. And k is negative 5. And there is my vertex form equation. So what I want you to do right now, we're going to write down really quickly, we're going to go ahead and write down the next example. Number 2 is a quadratic function with a vertex of 2, 8, and a point of 0, 0. What I want you to do right now is I want you to write down your little table over here, your h, k, x, y, a, and I want you to fill in as many of those as you can. Do that now. Okay, so what I like to do, and I've been doing it up until now, but with the vertex, I always put a little h and a little k above those variables, those values and the coordinates, and then I put my x and y above the other point. Okay, so for h, you should have 2. For k, you should have 8. For x, you should have 0, and y, you should have 0. And we don't know what a is, so we're going to leave that blank. Let's go ahead and substitute in. I'm going to write the formula first. Y equals, what is it? A times x minus h squared plus k. And I'm going to start substituting. You substitute real quick and see if you get the same thing that I do. Okay, so you should have 0 equals a times 0 minus 2 squared plus 8. All right? I want you to try to solve that. and see what you get for your A value. I'm looking for your A value. Take a moment and find your A value. Okay, I'm going to solve the inside. Okay, that gives me negative 2 squared is 4a plus 8. I'm going to subtract 8 from both sides. Negative 8 equals 4a. When I divide both sides by 4, I get negative 2 equals my A value. So my new function, so did you all get negative 2? Yay, go you. I want you to really quick, I want you to write the new equation in vertex form. And what you should have is y equals negative 2 times x minus 2 squared plus 8. Okay? So far, hopefully, you're feeling pretty good about this. All right, what I want you to do now is I want you to try question number 3. Okay, 3 has a vertex of negative 3, negative 6, I'm sorry, that's 3, negative 4, negative 4, 5, and it passes through 1, 0. I want you to try this problem, and I want you, what you're going to give me now is you're going to give me an answer in vertex form. So you're going to do the whole thing. Take a minute or two and do that right now. Okay, so what you should have is H, K, X, Y, A. H is negative 4. K is 5, X is 1, Y is 0, and we don't know what A is. Okay, so Y equals A, X minus H squared plus K. 0 equals A, 1 minus negative 4 squared plus 5. 0 equals A times 5 squared plus 5. 0 equals 25a plus 5. We're going to subtract 5 from both sides to start solving the equation. Negative 5 equals 25a. Negative 1/5 equals a. So my equation is y equals negative 1/5 x minus negative 4 means plus 4 squared plus 5. And that is my equation in vertex form. We're going to save the last problem on that worksheet, and we're going to do it in class tomorrow if we need to. I want to have one for us to work on. Hopefully you don't have any questions, and if you do, make sure that you've written them down so that you know what to ask me tomorrow. Thank you.